anyone who's ever designed and built something from the ground up is pretty aware that it's not hard to build yourself into a corner and actually make something unbuildable. There are certain aspects of this that I am a little bit concerned about, though at the time when I sort of pulled the trigger on all these laser cut parts, I was pretty dang confident that I was going to be able to put it together. But now looking at it all in front of me, I'm feeling a little bit nervous, but there's only one way to tackle this, and that's head on. I'm going to start with this guy, the burn chamber and riser. I've taken a few lessons that I've learnt from the last design and incorporated some features that I built into the potbelly stove, hoping that this will be able to cope better with long burns, able to run continuously for the people who might be wanting to use this in colder climates. And we're going to start with this. I'm already regretting some of my design choices. For instance, there's going to be a part that goes in here, so it's just going to be a pain in the butt to weld once I get You might have noticed that I used filler wire on these two welds because on this part of the burn chamber, it's where it's going to experience the most amount of heat and therefore the most amount of stress. Hi, Baba. Something that one of you pointed out in the last video was that the stove was suffering from not enough airflow, and that was causing the wood to burn back up into the hopper. And I couldn't agree more. So this has just gained 300 mil. The riser was going to be 700 long. It's now 1 meter. That was as unpleasant as it looked. So this is the new heat exchange, but as you can see we have a slope design, and I'm drawing a lot of inspiration here from the benzene boiler or Kelly kettle. The heating chamber is very thin and it gets larger. Well, we're heating a very small amount of water, which is good. This is closer to the heat source. So that's going to get that really hot really quick, and we're just sort of gradually building up. And yeah, the one thing I'm wanting to be really careful about is getting the top of this chamber sitting just about there. That way we're never really going to get an air bubble or something building up in this, which is something I'm a little bit concerned about. So gas is going to come up through this hole and fill this entire chamber, so that as I'm welding on the outside, the gas is going to be shielding the weld on the inside the same, if not better. What this is going to do is really help with the strength of the weld. It's also going to help with its corrosion resistance, and just purge welding is the proper way of doing this. So I'm going to have a cup of coffee. While I wait for this thing to fully purge out. And yes, this is my wife's cup. Don't tell her. Oh yeah, and just like that, we're done. The prudent thing to do now is to just make sure that it actually is watertight. So oh. Yeah, okay, well, it's full. I'm not sure how to film this and actually make it seem interesting. It's I'm just trying to get each rivet lined up, and every little bit of error that I have introduced into the system, it all accumulates to this, where the holes are jolly close, but just not close enough to go through. This was cut, well, 7 months ago, and since then I've got my clearances a little bit more refined, and I can, anyway, I don't usually have this sort of problem, but this is an older design. Marge, it's those jolly kids on the roof again eating corn. I'll try and jam some insulation in there. So this is the maybe controversial bit. We're looking down inside, down around the riser. That's the water heating chamber. And I was going to pack this thing full of insulation. And then I sort of stopped and thought about it for a minute. I went, well, there is advantage to that in that we're going to keep all of the heat contained inside the riser, which will create better draw. But then I'm like, that pretty much means that if the insulation does its job, we're only heating this chamber from one side. What if all of the heat generated from this riser, which will fill this chamber, was heating this from every side? I'm starting to think that maybe, and I'm going to have to test this is just my thoughts right now, is that if I leave this uninsulated, the heat generated all the way around this riser, instead of being contained, will be able to, well, it will heat more of this, theoretically. I need to give it a go. Plus, I kind of want to be able to take this cap off and just check and see how this is going for the testing process. So if this doesn't have insulation in it, that just makes that a lot easier. And I'm not sort of handling fibrous, nasty insulation. Like a ball. So clean, but I'm so happy with that. There's no smoke at all. Really, really good. That's a mixture of hardwood, pine, just whatever was laying around. And I just threw it in there any which way because that's sort of, if it can't handle that, it's not going to be very easy to use, and that is doing a wonderful job. And that's it there.